Welcome. This is graphing exponential functions when the b-value is between 0 and 1. So that should give you an idea what kind of exponential function it is. If the b-value is between 0 and 1, you should be thinking that's exponential decay. It's got to be above 1 to be a growth. So we're going to see a lot of curves today going down this way. Okay? So graph each exponential decay, 1/2 to the x minus 5. They've put the parent function in here, a 1/2. So every time you move one to the right, it's half the height of the one before it. That's what that 1/2 growth factor does. Remember, when we do sequences, we look at the number and it's half as big as the one beside it. Graph of g of x is a translation of the graph by how many units and in which direction. Hopefully you're looking at that saying, well, it's not up here with the x, so it's not an h, so that's a k. And I would hope that you took the asymptote. Remember, we always want to move the asymptotes. Asymptote and moved it down 5, because that -5 on the k would have moved it down to here. And now what I refer to as your vertex would be moved right to that -4. And then go ahead and regraph. On the next one, now we have a horizontal shift of 2 and a k shift of 1. Now I handle these a little bit slightly different. The parent function f of x is, well, let's look at this. They aren't going to tell us what the a value at this time is. Remember how last time it was half the height and went from 2 down to 1, so that showed us it was a 1/2. Now we can figure it out on this one. It goes from 3 down to 1, so we know it's a 1/3 to the x. Okay, now it says that the graph of g of x is a translation of the graph of f of x by how many units and in which directions. I always move my asymptote first. So the asymptote, the k value moves up 1. So we take this that was at 0, we move it up to 1, and we know that the graph is no longer going to touch there. That means that this vertex point moves up 1. Also means that this point back here moves up 1, because our shift doesn't change. So you bring it through these 2 points and right along that asymptote. Oh, I forgot one thing. I apologize. Don't put that point in yet. I just looked back at the problem and remembered we have a k or an h shift as well. The h in this formula is at a -h as well. So if you have a +2, you know that it's a minus a -2. So we're going to the left 2. So take this vertex and move it left 2. Take this point, move it with both transformations, up 1, left 2, and now graph your new function through those 2 points. It has now shifted to the left and up. Okay, make sure that it goes right alongside of your asymptote, just like the parent function did. It can't go through it. Then they're going to ask you to explain those transformations. And they'll probably maybe have you sketch a few other things, have you give them an evaluation of another graph here. How is the graph 0.25 related to the graph 0.25 to the x? And they've got a little h shift here. Here they have a little h shift. And now they want you to compare how is this one with this h shift related to that one. Be prepared on your final exam. I'd love to have you take a transformed function and transform it again, or explain the difference from one transformation to another. I will give you a hint here. You don't talk about a shift of 3. You're actually going from the +3 clear down to the -3. So it will be a shift of 6. Make sure to ask questions if you don't get that right or if you need to verify your answer. Okay, next, make sure that I'm on the camera right. Okay, graph each exponential decay function. So here we have a decay of 0.25. I always like to bring that back into a fraction. So I just convert this. This means 4 to the 1 over 4 x. So that's telling me that I have a decay of 1 to 4. It's also telling me that I am going to stretch it 4. Okay? So the first graph of the parent function, 0.25, the graph of f of x is shown at the right. And we can see that here. It goes through at 1, and then it also goes through up here at 4. So it reduces by a factor of 4 because it goes from 4 to 1. So we see the 1/4 decay. Now we want to stretch it by 4. Okay? So remember, when we are stretching, that we want to take that factor of 4 and multiply it by each of these points that we have. So we're stretching, we're getting 1/4 to the 0th power is 1. Now we multiply it by 4. So 4 times 1 is 4. It's going to cross right through here. This 1/4 right here, 1/4 to the 1st power is 1/4. Multiplied by 4 will be at 1. 1/4 to the 4th to the, 1/4 to the negative 1st power is 4. 4 times 4 is 16, so that's stretched way up there. Now you're going to draw your line down through those 2 points. Still going to get ever so close to that asymptote, but it's really stretched up there as it comes down. Okay? Now we're going to take a 1/2 of the 1/2 to the x function. So the parent function is just this without the a transformation. So it's 1/2 to the x, it's the b value. Okay? Graph the 1/2 to the x on the f of x coordinate plane at the right. So we come over, 1/2 to the 0th power is 1. Anything to the 0th power is 1. Now as we go back this way, we know that we were twice the height, that we became half of that height. So it would be 2, half of 2 is 1. If you want to go back one more, half of 4 is 2. Half of 8 is 4. Half of 1 is a half. Half of a half, a quarter, an eighth, a 16th. So there's your parent function. That's your f of x function. Okay? Now, they want to shrink it by a half. So each of these, we would take that point and we would go half the distance to the x value. Down here, it's very hard to do that. But here, not so hard to show that transformation, that shrink. Okay? It's just half the distance to the x-axis. Then go ahead and answer questions on that. Down here, they're going to give you others to look at. Relate them back to these functions, what you've learned up here. Okay? They're having you look at a graph that has a stretch of 9 and how it's related to this. How you would calculate it, be specific so that when you're looking at your notes, you could actually do it. This one is shrunk by 1/3 on this function. So again, think about how you get your points, and then you just take 1/3 of that or divide it by 3 to get it smaller. Now they're going to ask, well, what's the comparison between 1/3 clear up to a stretch of 9? Okay, so sometimes what I say is actually take your stretching and your shrinking and figure out, what would I multiply 1/3 by to get to 9 over 1? If I multiplied it by 3, it would only equal 1. If I multiplied it by 9, Those would cancel, it would only equal 3. I need to multiply it by 27. So to go from these points on your graph up to these, you would have to multiply the stretch from the x on this graph 27 times to get up to that one. Okay? Use the properties of exponents to explain why the graph of 1/2 x minus third may be considered a vertical stretch of the graph 1/2 to the x. What is the factor of the vertical stretch? I'd just like to do this with you. 1/2 to the x minus 3. Remember from our properties of exponents that when we multiply exponents, we are adding them together, which means if it's a negative exponent, it would look as though we're subtracting. Another way to look at that is with our properties of exponents, we could have 1/2 to the x divided by 1/2 to the third. Okay? So now let me go ahead and go this way first. So this would become 1/2 to the x 1 to the negative third over 2 to the negative third. The negative values cause it to flip, so this becomes 1/2 to the x times 2 to the third over 1 to the third. 1 times 1 times 1 is 1. 2 to the third equals 8, so this actually equals 1/2 x times 8, which would put that in the front. That's how it could be a vertical stretch. Okay? Kind of neat to see how we can look at that. On this one, we would have (1/2) to the x over 1 cubed, 2 cubed, that's complex fraction, 1/2 to the x over 1 over 8, and remember we flip the fraction, so it becomes 8 times 1/2 to the x. Either way is a correct way to show it, just two different ways. Okay? That brings us to this modeling problem on here. The modeling, we're writing an equation from the graph, just like we did yesterday. So the first thing that we want to look at, we want to establish our k value. The k value comes off the asymptote. So you can see our k value here is at -1. Okay? So now we put the -1 in for the k. And we say, well, when b is at 0, it is crossing at 1, right there. Okay? If we take a, any number to the 0th power is equal to 1. And we put a 1 in there for where it's crossing. We add 1 to both sides, and we find that 1a is equal to 2. So we have a stretch factor of 2. Now we would plug that in next to the b for the a value. So we have 2b to the x minus 1. And now we take the xy. They give us -1 and 5. So we put 5 and -1 in for our x and y values. Okay. Anything to the negative exponent, we put on the bottom in a fraction and make it positive. So that's our next transformation of the equation. Now we add 1 to each side. We have 6 equals 2 over b to the first. Now what I would say is multiply each side by b to the first. This will cancel. We get 6b equals 2. Divide each side by 6, and we get b equals 1/3. Okay? Now we write the final equation. We had the 2 for the a value. We have 1/3 for the b value. We have no h shift, and we have a k shift. Okay? They're going to ask you some reflect questions on that problem. Ask questions in class if you have difficulty answering it. I think as you go back and look at what you've done, I think that you'll be just fine with it. Now we're going to look at a decay, a depreciation rate. Now remember, when we decay, it goes down from our constant. If something holds its value, then it's at 100% of its previous value. That keeps it. If it's $6, and it doesn't go up or down, then it's still at 100% of that $6 value, so it's at $6. But with a decay, when it says that it depreciates, that tells us it's going down. So when it says it depreciates by 11%, we're going to subtract that and get 89%. Interesting how they do it in the equation. They show it as decimals, so instead of 100%, they show 1 minus whatever your rate is, 0.11. That's how they will initially show it. So the initial amount that we start with, the car sells for $22,300 and is known to depreciate at a rate approximately 11% per year. Write and graph the function that gives the v value of the car after t years. Then find the value of the car after 7 years. So the initial amount was $22,300. The decay rate is 11%, and the decay factor is 1 minus the decay rate, so it's 1 minus 0.11, which brings us back up to what we did earlier. It's going to be 0.89. Okay, less than 1 it will decay. So the v of t is 22,300, our initial amount, times 0.89 raised to the t. Okay, I would go ahead and graph the function on the right. You could take this and probably the easiest way is just to plug in these values. So 22,300 parenthesis 0.89 parenthesis closed raised to the 2 years equals 17,663. So at 2 years you'd come up about 17,000. Now at 0 years, remember 0 years is at the very beginning, it's your initial amount, so that would be about 22,300. Okay, and then I'd go to 4 years, 6 years, 8 years, and 10 years. Specifically, they're asking 7 years, so I would make sure and do that. So 22,300.89 raised to the 2. Oh, we already did that. 17,663. So sorry about that. 22,300 times 0.89, parenthesis close, raised to the 4 is about 13,991. So there's 10,000, there's 15,000. So I would put it, that would be about 2,500. So I would put it about right in there. That means our other point needs to go a little bit higher. 15,000 plus 2.5 would be 1,750, and it was 1,760. Okay, at 6 years, Well, let's go to 7 years so that we can just get that one done for you. 22,300.89 raised to the 7 equals 9863. So over here at 7 years, go up to about 9. This would be at 7,500, so 8,000, about 9,000, right close to the 10 mark. And then I would go ahead and do 10 as your final point there, 22,300. Parenthesis 0.89 raised to the 10 equals 6954. 6954 would be right about there, so I've got a nice curve coming down. Okay, so you should be able to fill this stuff in. If you have problems with that, let me know. Tomorrow you'll get into class, we'll answer a few reflections on that problem, and then we'll do the practice. Have a good day. Thanks for joining me for lesson 3 out of this exponential unit.